Um, and so hello and thank you for tuning in to another Diversity and Inclusion Forum hosted by We Stand in partnership with We Care and Reach Up Inc. We Stand is an acronym that means we stand against negativity and discrimination. What is it that we do? We work together to facilitate a greater understanding of the diverse communities that NEO serves and the complex issues that affect these communities, allowing for the creation of constructive dialogue and healthier interpersonal relationships. Today's webinar will provide an update on the impact of the SARS-CoV-19 variants and the need to continue promoting vaccination, in addition to following the CDC guidelines to end the current surge of infections and decrease the mortality and morbidity associated with the pandemic. And with that, I would like to introduce Dr. Hill, and from there, she will introduce our esteemed guest panel. Dr. Hill is a tenured professor and associate dean of clinical practice and past chair of the USF Canisius College of Pharmacy. Dr. Hill received her doctorate of pharmacy degree from Florida A&M University. She received her postgraduate training in the neurosciences from the Neuroscience Research Institute and holds a certificate in medication management. She is also a fellow for the American Association of Colleges of Pharmacy and a consultant pharmacist in the state of Florida. One of her duties as the Associate Dean of Clinical Affairs includes her serving as the project manager for We Care, a community-based participatory research entity within the College of Pharmacy, where she coordinates activities within the community to recruit, retain, and educate minorities on research participation. She has labored alongside Dr. Sneed in providing and coordinating the workshops and other presentations related to the management and treatment of COVID infection, and has presented several presentations to pharmacy and community audiences about the mental health and neurological aspects of the pandemic. Dr. Hill, would you like to take it from here?
Yes, thank you so much, Ms. Jackson, for that introduction. And thank you again for allowing us a second opportunity to come back and speak to your group. And we'd like to say good afternoon and happy Friday to everyone who's on board. And I wish that we had saved some of the time you went to introduce me so that I could use it to describe our speaker for today. So hopefully many of you had a chance to hear Dr. Sneed the first time that he spoke. And so I just want to remind you a little bit about his credentials. So Dr. Sneed, like myself, is a pharmacist, and he is the founding dean, as well as the senior associate vice president for USF Health. And Dr. Sneed is qualified today to talk to you about COVID and give you this update because he has a bachelor's of science degree in biology with a concentration in microbiology. And he is probably one of the most well-read pharmacists definitely that you would find, and clinicians this side of the equator as it relates to COVID. And he and I, are texting and emailing each other and the whole team constantly talking about COVID to the point that my 6-year-old knows the symptoms of COVID and can eloquently express that to her peers. But it's just been such a pleasure to work with him, not just on COVID, but other things. Dr. Sneed is an ambulatory care specialist. He did a residency over at Bay Pines where he trained and actually got into areas like metabolic syndrome and chronic disorders like diabetes. And he still works and practices as a pharmacist over in our Health Academic Center. And so you'll see that rarely because most administrators in academia typically just do the administrative duties, but he is certainly a role model in that he still has his hands in practice. And throughout the pandemic, not only has he been educating the community and all, but he's also been involved in several of the studies related to the vaccines. And so again, he is so appropriate to talk to you today and give us an update. We do know that this pandemic, we thought by this time would have been gone, that this would have been a memory. And unfortunately, it's still here. So we do hope that if you have not gotten vaccinated, you will consider after this talk. So I do want to also just say again, a thank you to Ms. Jackson, because we were hoping that we would get more people than we had the last time. And looking at the numbers, I think we made it. And with that, I'd like to introduce some of the other individuals in our team. Dr. Deborah Austin, who you can see. And then the reach up screen is our mystery person in the name of Mr. Michael Morgan. But these are the talents that are associated with Reach Up Incorporated, which is a community-based organization that provides services in the areas of fetal and maternal health, as well as all things related to family. And so we're grateful for them because they allow We Care to have the visibility that it has. And we work also alongside Mr. Hiram Green, who is our community outreach coordinator, public relations person. And I don't think he's joined us yet, but he's trying to get on. And then we also have a student ambassador and a few others, key others that allow us to fulfill our mission. So with that, I will pass the mic to Dr. Sneed, and we encourage you to please use the chat function to place any questions that you already have. And then Dr. Austin, Mr. Green, as well as Ms. Jackson will comb through the questions after Dr. Sneed gives us a few updates. So thank you.
Well, Dr. Hill, thank you very much again for that very kind introduction. And Ms. Jackson, it's always a pleasure to interact with you personally. I love the job that you're doing. Also, we have present here on the screen, Dr. Deborah Austin from Reach Up Incorporated, our trusted partner. And it sounds like I have a contract in perpetuity with her for volunteer work, which I readily accepted. We're just very thankful for our We Care team overall. One thing I wanted to kind of prepare you all for, hopefully many of you had an opportunity to see my earlier presentation when really we were trying to educate people about COVID-19, a little bit of the cellular process, a little bit about the vaccines and what people could expect from the vaccines. As we have moved into the summertime and now we're headlong into the fall, well, we've all seen the emergence and now hopefully the downslide of the Delta variant, and there still continues to be a little bit of a misunderstanding about Delta, and certainly a great deal of confusion about the boosters and third dose and should I, shouldn't I, and quite honestly, we're trying to sort all of that out even as clinicians right now. So what I'm going to do, I'm going to take you all in a little bit into my world as a clinician, as a researcher and scientist, and we're going to, and we've been experimenting for about a 2-week period now. And how can I better explain to the public some of the things that we are constantly talking about on the scientific end, and to help you all understand a little bit more about what you have been witnessing over the past 2 to 3 month period, and then hopefully give you more information and more education about why hopefully you yourself either should be vaccinated if you are not currently vaccinated, or why you should be encouraging other people around you to get vaccinated. And as I'm starting here, I just want to first acknowledge just this past weekend on Sunday evening, my wife and I were driving from South Florida, and we came across Alligator Alley, and we're driving up 75. And I looked over to my left, and I saw NEOGENOMICS. I saw this beautiful building right beside 75, and I'm certain that Ms. Jackson, please let me know that that's the very same company that we have here. I would hate to be giving somebody else credit for that beautiful building I saw.
It is. It's actually our new headquarters.
Yes, I figured it looks like a new building, and I said, I've driven down this road for many years, and I just don't recall seeing such an attractive building in the evening. I'm sure you all have seen the evening pictures as well. So I just wanted to give kudos and congratulations for all of the people from NEOGENOMICS for really getting such an established location. We're going to get started here. So if you could just give me a moment to share my screen, we will get started. Okay, there we go. Okay. Okay, can you all confirm that you can see that slide?
Yes, sir, we can see it.
Okay, very good. Okay, let's get started. So I'm going to start right here. And I'm going to, in the very beginning part of the presentation, I'm going to make a fairly, what used to be a provocative statement, even for my colleagues, but I think is becoming more evident and more true. And I'm going to give you evidence of that here in just a moment. The statement I'm making to people now to really help them understand the departure away from where they've been thinking and into the location of where we want them to be thinking. SARS-CoV-2, or the virus that causes COVID-19, is not a respiratory virus. Okay, I'm going to make that statement again. It is not a respiratory virus. It is transmitted through respiratory means, but it is what I consider now to be a cardiovascular virus. And I'm going to share more of the evidence for that in just a moment. And so when you look at the photograph here on the right, we're all familiar by now with the red spike proteins on the outside shell of the SARS-CoV-2 virus, or I'll just call it the SARS-2 virus. And I may have mentioned this to you before. If not, I want you all to kind of picture that if each one of you had 3 broccoli heads, okay, or for those of you that like cauliflower, if you had 3 cauliflower heads and you found a way to kind of braid them together into one unit, into one big unit, that's what each and every spike protein that you find on the SARS-2 virus, that's what it's comprised of. 3 distinct components that have kind of been bound together. And I want you to also think of that spike protein as being very similar to Velcro. And you know, Velcro can stick onto wool in a very secure and very rigid fashion. Well, in our body, we have a receptor, and almost every virus really has to have a receptor to attach onto. Viruses in and of themselves are not living things. I know you say, well, what does that mean? It's very difficult for the virus to replicate on its own, and it really does need a host in order to replicate and flourish as a virus. And so the red spike proteins attach onto a receptor that every human being on this planet, 7.7 billion people, have on the planet, and it's called an Ace2 receptor that's shown here in the middle image. And it's the only receptor that the SARS-2 virus can attach onto. But the Ace2 receptor is found throughout the body, which I will show you in just a moment. And it's part of the cardiovascular system. And so when I make a statement that we are talking about a cardiovascular virus, I'm talking about where the virus has to attach onto. And when the moment it attaches on, it gains entry into the cell, and thereby begins an entire biochemical process after that we have learned a great deal about over the past year, and really helped me understand a little bit more about why the Delta variant became so dangerous. And so I've shown this cartoon before. This was one of the first images that came out last year, published in JAMA. It says online, April 13th of 2020. And here you see on the left at the very top that the SARS-CoV-2 virus attaches onto the Ace2 receptor, and that unlocks an entire mechanism of how it gains entry into the cell, and then it begins to unfurl. So I make this statement every time because I want everybody to understand. And it's critical that you walk away with this particular understanding. That RNA strand inside of each and every virion, we call them, each and every virus cell, that RNA strand is very dangerous. And there's nothing that we have done in the way of vaccines, monoclonal antibodies, a new medication that's coming out from Merck here very soon. There is no therapeutic that we have tried that is more dangerous to the human body than that individual RNA strand that I have encircled there in red. that RNA strand, it kind of takes over the machinery of your cell and it directs your cell to change over and start using your proteins to now repackage itself and make and replicate into many more viruses. And so it's really important to understand that. Also, number two, when we first encountered the SARS-2 virus a year and a half ago, it replicated relatively fast, we thought. But then Delta came along, and Delta replicates at an extremely high rate. Okay, and I'll show you exactly how much in just a moment. And so now we're not talking about one cell in and then one cell coming out. We used to be talking about one cell in and maybe 100 cells coming out. But now we're talking about one cell coming in and 1,000 cells coming out per cell coming in. So it replicates at a very high rate. And so what we wind up finding, and here highlighted in the middle parts, highlighted in yellow, I wanted to show you that from the very beginning, scientists all over the world, including right here at the University of South Florida, we began combing entire libraries of medications to figure out exactly what medications were already on the market that we could potentially use to treat, to try and stop the virus from gaining entry, replicating at the rate, and then therefore infecting people and leading to really what has turned out to be just a very terrible virus. And here I'm going to call timeout for a moment, because right before I came on, and I do it almost every day, as of today, according to Johns Hopkins University, we are now at 698,555 people who have died from COVID-19 here in our country. And so either later on today or by the time we all go to sleep tomorrow and wake up on Sunday morning, we will have crossed the 700,000 person death mark for people who have died here in this country. And that's a very sobering number. I mean, we thought it was terrible when we crossed 100,000, and we thought it was terrible when we crossed 200,000 and 250,000. We thought we were at the end of it when we came to 500,000, and now we wake up and we're crossing 700,000 people in our country alone that have died. And so let me just explain a little bit more about the virus. I'm going to try again to make it into a scientific term and translate it into ways that we can all understand. One of the first things that the virus does when it unfurls in that RNA strand, it directs what we call non-structural proteins to develop into one big unit. And then that one big unit is divided into 16 other units. So it will be very similar if everybody from NEOGENOMICS, if you all came together and you were at a retreat and you had all of you in one big room and you divided everybody in the room into 16 groups. 16 groups for every one of you from NEOGENOMICS. And it's really important to have to understand that we have found out scientifically that 3 of the what we call NSPs, the non-structural protein groups, 3 of the groups, 1, 6, and 13, their job is to go in and to basically deactivate the early part of your immune system from even recognizing that it's there. So if you had NEOGENOMICS and you all divided into 16 different groups, it's like we told group 1, group 6, and group 13, your job is to go and deactivate all the cameras in the hotel so that nobody will know that we're in the hotel and what we're about to do and all the fun that we're about to have. And that's exactly what these proteins do in our body. And I'll show you more about that in just a moment. And so it's not uncommon for viruses to do this, okay? This is not a new phenomenon. We've known it forever. But when Delta came along, and by the way, this particular virus has been doing this from the very beginning. So it's nothing new. But now when we add that onto a highly replicatable virus in the body, it has turned out to be something that can overwhelm the immune system in a very, very, very vicious manner. It actually turns on inflammatory proteins in a higher manner. And therefore, people got sicker quicker than they did before we had Delta. So it prompted me to try and figure out what was the mechanism that made Delta so much different than what we had encountered before. And therefore, I just wanted to make sure that we kind of understood a little bit more. And I'll show a little bit more about this in just a moment. So yes, 1,000 times more than the original SARS-CoV-2 virus that we all encountered that killed so many people from the very beginning. So this slide just kind of talks a little bit more about what I just said. Bullet point number 2, 1, 6, and 13, disable what we call type 1 interferon. And interferons are your body's initial natural defense against the viruses. It's what they do. It's what it's for. Okay, and so it says preventing early antiviral response of the innate immune system. And they are all type 1 interferons are also anti-inflammatory and anti-proliferative, meaning that their job, the type 1 interferon, its job is to try and prevent the virus from proliferating at such a high rate. But 1, 6, and 13, they actually deactivate the type 1 interferon group. And then as a consequence of that, it actually goes on, there's a interferon type 2 that increases very quickly and leads to even higher levels of inflammation in the body. So we went on a little bit further and I said, well, let's try and show this in pictures. And so I really wanted to help everybody understand that the coronavirus overall is not new. It's been around for a long time. Many of you may recall that we had the first SARS, what we call SARS-1 now, back in 2002, 2003. That particular version of coronavirus actually was more deadly than what we are encountering right now. But it didn't replicate nearly as much and did not spread nearly as much around the world. As a matter of fact, only 8,100 people actually developed the original SARS back in 2002. But it killed about 800 people. And so that a lethality rate of about 10%. We have not encountered that same lethal rate, thank goodness, for SARS-CoV-2. And you see here across the top that they attach onto the Ace2 receptor right there in the middle, the MERS version of coronavirus that we had in 2012. It found a different receptor in our body to attach onto, which is a whole another 1-hour lecture. And then here at the very bottom, you see NSP1 16, 1 through 16. And again, 3 of the groups go in and deactivate the early alert system for your immune system. Now we've known about this for a long time. And so this image you're looking at came from a year ago. And you can see on the far left, and I circled in blue, to the left of the dotted black line in the middle. And that line typically indicates when symptoms began to occur in most people. And so you could see that people were being infected anywhere from 7 to 10 days before that even began to occur. But the replication rate was fairly low. In the body, if you take a look, the purple dotted line and the green dotted line, those are your natural antibodies, okay? So that's another myth that we kind of want to sort of dispel. Now, if you had come into contact with any version of coronavirus in the past, your immune system has kind of been primed to be able to respond a little bit quicker for many people. And that, again, that's a whole nother 1-hour lecture. But what we found when we had the SARS-CoV-2, because it has evolved and mutated, that those original proteins kind of sort of deactivated the early part of your body's ability to be able to respond quickly. And so therefore, your body does not have circulating antibodies that were engineered and geared towards SARS-CoV-2 or the COVID-19 virus. They're just not running around your body waiting unless you have vaccinated yourself. And so you can see here, it takes your body almost a week to begin the process of rapidly building those antibodies to protect you against the SARS-CoV-2 virus. And when we encountered the Delta variant, and it still had the ability to knock out the early phase of the innate immune system, but replicate at a very, very, very high rate, what we found is that it overwhelmed many people's immune systems. We found much younger people that were being infected and filtering into the hospitals. And we even found much younger people that were dying that had not been dying early on in what we call the wild type or the original version of the SARS-2 virus. So we have to really understand that when Delta emerged, and it only emerged because it had a chance to learn the human body a little bit better. It found a better lock and key system to get into our body. It found a better way to replicate more rapidly. When that occurred over the summer, that's when even vaccinated people, we began to hear about the breakthrough infections. We saw much younger people succumbing all the way down into very young children. Over the past 4-week period, we've had over 1 million children infected with the virus, and many of them became sick enough to go into the hospital at a rate that we had never seen during the entire pandemic in our country. So again, I just wanted to kind of try and scientifically explain to you why we are witnessing such a difference with the Delta variant versus what we did before. Now, the other thing, I somewhat apologize for this. I got a little bit off as I had to readjust the slide very quickly for you, but that Ace2 receptor, when I call it a cardiovascular virus, you can see exactly why we call it that. You can see that the Ace2, any organ that you see colored here on the slide right here kind of shows you where the virus can actually attach onto. And I really want to kind of highlight for many of you out there, especially our men, some of the reproductive organs here that are highly susceptible to having the virus attach onto it. And remember, the moment it attaches on, its job is to gain entry into the cells to replicate. And eventually that high rate of replication leads to actually the cell death of that particular cell. So I wanted to kind of really highlight for you that the virus can attach onto your heart. Last evening, I had the really cool pleasure of doing a COVID web panel with colleagues from Tampa General Hospital, and we did it for the Cayman Islands. And so I wanted to know, well, if I do this webcast, can I get free tickets to the Cayman Islands for next summer? They told me no, I couldn't. So I the volunteerism, it was all good. But the gentleman I shared the panel with last evening, he's actually a liver transplant physician, a surgeon. And he began talking about the number of liver transplants from SARS-CoV-2 that they had not been seeing long before it began, long before the pandemic occurred. Also, you can see on the left arm here, it's on our right side, but that's the left arm of the individual, that we have the Ace2 receptor in our blood vessels. And also, and again, an area that Dr. Hill is much more proficient than me, we have found that the virus can crawl along the olfactory nerve in the nose and gain access into the brain, thereby leading to brain fog. And now we're even finding that it can actually have a profound negative impact on the gray matter of the brain. And so again, we just want to make sure that we're understanding that even though we call it a respiratory virus, and many people across the country and all around the world are saying it's just like the flu and I'm coughing, and well, it's actually a cardiovascular virus to me. And it's attaching onto cardiovascular receptors, which are cardiovascular organs, leading to organ damage, profound kidney damage. We're finding people with cardiac conditions. We'll talk about that more in just a moment. And so those individuals who have diabetes, well, before I get to that, let me just, again, show you all the organs and all the bad things that can happen to you as part of your cardiovascular system when the virus comes in and infects these different organs. Again, the neurological, the renal, the gastrointestinal. We can have profound clotting throughout different parts of the body, including inside the brain. And also the myositis and myocarditis and other cardiac arrhythmias that could develop because of damage to the heart. This particular slide kind of shows a little bit more of the continued theme of it being a cardiovascular virus. This particular article talked about type 2 diabetics and really was showing that anywhere that any part of your organ system that may be negatively impacted, by type 2 diabetes, which we know diabetes can cause profound cardiovascular organ damage, can also be affected by the SARS-CoV-2 virus. And so the dark gray boxes really show the impact of what can happen to that organ system should indeed the virus come along and attach onto and actually damage that part of the organ. And so we've heard a lot of discussion. We've had a lot of controversy around children and schools and masking. And of course, we now we've had vaccines approved down to 12. I'm fully anticipating we're going to have vaccines approved down to age 5 here fairly soon, probably by the end of this month in October. But again, children have the very same organ systems. They have the very same Ace receptor, but we feel that there are two things unique about children that prior to the Delta variant allowed them a little bit more protection against the virus than what we have currently seen with the Delta variant. The first thing is what you're looking at here. They, of course, children are little humans, okay? They're little adults, and they have the very same organs that we have. And they also have an Ace2 receptor on those organs. However, we feel that those receptors have not had an opportunity to mature in the very same way to respond to things like blood pressure changes, glucose changes, and other things around the metabolic components that we all experience as as adults. So we felt that that was kind of a protective component on the one hand. On the other hand, as I talked with some of our virologists here that are also doing vaccine development right here in this building, one floor above me, and I've grown an even deeper relationship with them during the past 18-month period. They were also sharing that children also have a much higher functioning early interferon system than we do as adults. And so we felt that early on, they were being protected at a higher rate because of that early immune response from the type 1 interferons that actually now is being overwhelmed by the fact that the virus can actually have an early deactivation of that for about a 3-day period, thereby allowing it to overrun the system and then gain traction, replicate quickly, and get into and cause more illness in children. And so now I just want to spend a little bit of time talking about giving further evidence of the Delta variant and the impact. And you all may have heard of other variants, and I'll talk about that here at the very end of what I'm showing you. Yes. So if we start here on the far right bar graph here in the B.1.617.2, the dark orange area, that is the Delta variant. And so at the beginning of June, it comprised about 2.8% of all the cases that we found when we went looking for the genetic components of the variants that are out there for people who have been infected. As we moved along, I'm sorry, let's go back. This was actually in late May, it was 2.8. In the early part of June, June 5th, it became about 10% of all cases out there. And then about 1 month later, it was up to 57%, Delta being 57% of all cases out there. And then I just kind of sped through to last week, where we find that the Delta variant grew rapidly all the way up to 99.1% of all cases. But we also have the emergence, if you look here, of the Mu variant. And we're keeping an eye on that because we understand that the Mu variant has more mutations in it than the Delta. But the other thing that we know about the Mu variant, it still does not have the high replication rate that Delta does. And so therefore, the Delta variant right now is crowding out all of the other variants that potentially could be damaging to us as humans because of that very high transmissibility and high replication rate. But we are keeping an eye on it, even though it shows 0.0%. In the 2 weeks prior to that, it was 0.1%. And so they're keeping it on there because it has now been found in about 30, I believe somewhere between 30 and 40 states around the United States right now. And so again, just kind of show you all the Delta variant. We're keeping an eye on all the ones that potentially could cause a problem for human beings. And there you also began to see the Lambda variant that emerged, and also the Mu variant. And I get the question when I'm doing Facebook Live, and they say, well, how do you even know that we even have these variants out there? And so I kind of show this. This is what we call a phylogeny tree. And for our purposes, it's kind of like either 23andMe or Ancestry.com for the SARS-CoV-2 virus. They take the original version of the virus, and then they go back and they look for what genes or what other components of the proteins have changed and are a variant away from the original version. And then where did it come from? And so, oh, I took it out. I'm sorry. I was going to show you another variant that's not here in our country just yet, where we were showing that there's a new variant over in Africa. It's called the C.1.2 that actually has emerged from the genetic lineage of the Lambda variant. And so we're keeping an eye on everything, but it really does hearken why we need to get vaccinated. Okay, because if we continue to allow transmission from one individual to another, if we continue the transmission, we allow the potential emergence of new variants to occur. So I'm just going to share with you also, and I'm going to be coming to an end here in just a moment, and then we can get into a very, what I hope is a robust Q&A session. And so the other component of what are the monoclonal antibodies, and or why do we want people to get boosted, okay, or a third shot? And I'm going to talk about that, the difference between getting a booster and a third shot in a moment. The entire idea, and I showed you earlier how long it takes for your body to build up your own natural immunity once you've come into contact with the virus. The idea is that we want to have already stimulated enough of your own antibodies that should you come into contact with it, we don't have to wait for your body to manufacture them. We already have circulating antibodies that have been programmed to attack the SARS-CoV-2 virus the moment it gets into your body. Now, for people that have breakthrough infection,
I just need you muted out on us.
I'm not sure how that happened. I didn't touch anything, but I was saying what we clearly want from a Delta variant standpoint is that we want you to have as many antibodies on board, and even though it replicates at a high rate, it still will attach on. I'm going to show this video here in just a moment. The antibodies attach on to the spike protein, and therefore the spike protein is not allowed to attach onto that Ace2 receptor in our cardiovascular focused organs, which in turn will prevent it from replicating in your body. The name of the game is to shut down the replication of the virus. Now, for people who either were not vaccinated, or if you had a very significant breakthrough infection, we had the monoclonal antibodies available for people to be able to give you an infusion of those antibodies, but that's still not an optimal thing to do because we're only infusing it after you've been infected and after the virus has had an opportunity to attach onto the organs in your body. And we don't want that. We don't want that attachment to occur at all. So let me just show this video so you can kind of watch, and there's no narration here. But what we're watching are the goal here in this representation. The antibodies are attaching on to the spike protein, and therefore the spike protein can no longer attach onto the cells in your body. And if it cannot attach onto the cells, then eventually that cell will die, okay? And so the very last thing I want to share with all of you again, I know I hear it all the time. I'm not getting vaccinated. It hasn't been studied long enough. We don't know what the long-term ramifications will be. Well, nothing could be further from the truth. If you take a look here, let's pay attention to the left side. We discovered mRNA, messenger RNA, back in 1961. We'll go down very quickly to 2001. that's when we began doing clinical trials of messenger RNA in human beings. If you go down to 2014, you see the clinical trial of a lipid nanoparticle mRNA formulation for cancer. And so when we, and most of the early trials were actually focused on cancer, not necessarily viruses. And so we have all of that data, 20 plus years of data of injecting human beings with messenger RNA, and we understand exactly what it could do, what it wouldn't do. And so when people are saying, well, what's going to happen to you long term? Well, we have people that got injected 20 years ago that we're still capable of following today. And so we have a pretty good idea of what will not happen to people. Many of the fears that people are talking about have already been studied for over 2 decades. And the real beauty of where we are is that we learn every time. The majority of the mRNA vaccines did not hurt anyone, but it just didn't work well because we had found a way to protect it when it gets into your body. They were falling apart. Your body was attacking it too quickly. And so we had to find a way to get it into your arm safely without the mRNA falling apart. So when people are saying it wasn't studied long enough, nothing could be further from the truth. And then the very last area I want to touch on, again, I know we have a lot of conversation about a lot of compounds, a lot of natural products from the very beginning. And you see here, all of these compounds are natural compounds you're looking at here on the left. And on the right, they were showing the actual mechanism of where they felt that all of them potentially could work against SARS-CoV-2. And what we just have not found up to this point was anything that would prevent the SARS-CoV-2 virus from gaining entry into your cell when it attaches onto your Ace2 receptor. And this research has been ongoing from the time that we found out about the pandemic. So again, there's nothing further from the truth. And then finally here, when people are talking about the booster, just want to make sure we kind of understand what that means. So early on the far left, we had a strategy where you get 2 shots of Moderna or Pfizer or 1 shot with Johnson & Johnson. And then we gave it to you. Then we about a month later, we gave you a second dose that was going to give you this initial immune response. And we were doing that to try and protect you against the earlier version of the virus. Now, after about a 6 to 8 month period, when that early antibody response begins to go down, we give people a boost, but your body now remembers everything about what we call B memory cells. It remembers everything and says, hey, you know what? I've seen this antigen before. Let me produce even more antibodies because now we're being attacked again by the very same offending agent. And this is what we call the third shot, okay? Now, for people who are immunocompromised, for people who are elderly, or people who have particularly high risk, we had already determined that they were worthy of getting a booster because these individuals have very low and very quickly waning antibody amounts, the quantified amount of the antibodies. But for the rest of us that don't fall in those 3 categories, we are now recommending a 3rd shot for certain individuals that fall into certain categories. Okay, if you fall into a certain age category, if you have a healthcare condition, or for people who are at high risk of exposure, like healthcare professionals and teachers. So there's a big difference between getting a booster for people who are immunocompromised, people that have organ transplantation, they're taking medications that can have a negative impact on their body's ability to form antibodies, number one, and between getting a booster or getting a 3rd shot, that kind of is like a similar way of a boost, but not for the very same reason. And so I'm going to pause right there and get to your questions and have a very good conversation. But I want to thank you all. I know we've had a lot of COVID fatigue for an 18-month period. We have a lot of things on TV. But what I'm trying to do now for all of our communities is begin to explain a little bit of the science behind the Delta variant, behind why we want you to get vaccinated, and begin to kind of counteract much of the misinformation that we find on TikTok, Facebook, or even just sometimes in the barbershop. Dr. Hill, let's go ahead and get into a Q&A.
Okay, and I'm going to invite both Doctors Austin and Ms. Jackson to assist with the questions. The first one is from Marcus Silves, and it looks like you kind of probably have answered this one. He basically said, do you believe we will continue to see COVID variants come and go over time? If yes, why? And if yes, for how long will this dynamic continue? And if no, why?
Marcus, thank you very much for that question. There is no doubt that we're going to continue to see continued evolution of this current version of the coronavirus. As a matter of fact, we've already seen that, and we have, long before the original SARS-1 and now SARS-2, we had about 4 other versions of a coronavirus that were infecting people already. It was already partially, in a limited manner, kind of endemic as part of our existence here on the planet Earth. But when people got infected with it, it only produced a cold or a flu. And we knew, we've known for a long time that many people that had a cold or a flu, about 10 to 15% of those individuals actually had a coronavirus and not a flu virus or a rhinovirus. The flu virus causing the flu or the rhinovirus causing the common cold. And so we are expecting that over time, this current dangerous version that we have encountered will probably begin to wane in terms of how dangerous it is, but we are going to have to learn how to live with it for a period of time. And we have to keep in mind that in terms of human transmission, we're just now at this current moment here in October, we're just now beginning to approach a 2-year period where it has been circulating here on the planet in terms of a global pandemic. But we are going to, we're probably for a short period of time, we probably are going to have what I call an annual vaccine for the coronavirus. It will be engineered and will be programmed to be effective against the most dangerous version of the coronavirus at that time, whichever variant or mutation we feel will be the most dangerous for people. That will be the vaccine that we give, so you can build antibodies against that specific type. But I do expect it's not going to go away anytime soon. And if we had any hope of that happening, scientifically and clinically, our hopes have been dashed, because number one, here in our own country, we did not get enough people vaccinated quickly enough, number one. And then number two, we just simply have not vaccinated enough people around the world quickly enough to potentially try and bring this in before it has affected so many people negatively.
Thank you, Dr. Sneed. Dr. Austin, you want to take the next one?
All right, thank you so much, Dr. Hill. Maisha asked Dr. Sneed, with regard to the vax allowing our antibodies to recognize the virus faster, is this ability equal across variant types?
That's a great question, Maisha. You get the first gold star of the day. Dr. Hill and I are professors. We know we're teachers. We like giving out gold stars, so you get the first gold star of the day. So the one thing that we do know is that even though we are hearing a great deal about the variants, the antibodies that have been programmed from the current vaccines have continued to stand up to the test of the current variants that we have. That's why I mentioned those three, the 3 broccoli heads being kind of braided together. The current antibodies that our body is producing can still bind on to, we call them RBDs, or receptor binding domains. We can actually bind onto the virus, the spike protein, just enough to prevent that entry into your cells and replication. Now, that's another reason, by the way, that we are paying particular attention to the mu variant, because we are a little bit concerned that that particular variant may escape our current antibody pattern, okay? And then the other one, the C.1.2, that has not reached our shores yet, that has more mutations than anything that we have seen up until now. But as of right now, the current vaccines are holding up extremely well, well enough for 2 things. Number one, well enough to prevent serious illness, prevent hospitalization, and prevent death, with the small exception of about 2 to 3% of individuals who may have been fully vaccinated, but the majority of those people fell into one of those three categories of people who needed and required the booster shot. Great question.
I think Ms. Jackson is on, but I'm not sure.
Yes, I'm back.
Okay, great. All right.
Yes, ma'am. Oh, thank you for, looks like there was a question on here when I left and came back, it's gone, but there was a question about the incidence of Guillain-Barré syndrome and with the vaccine.
Yeah, Guillain-Barré, especially with the mRNA vaccines, it emerged earlier this summer, and this is a condition that number one can happen just because you've been infected with the virus. Guillain-Barré can happen with almost any virus, to be perfectly honest, and it's kind of when you get a supercharged response, an inflammatory response to your immune system being activated. That having been said, the overall, I can't remember the exact number. I will have to go back. I used to know it. I just can't remember with all this other data that's coming into my brain. But the overall incidence of that has proven to be very, very, very low. We understand that it can happen. And for those that it does happen, and we understand that we have to provide very significant supportive measures for them should it occur. But it is extremely low. But I also want to help you understand that Guillain-Barré has been reported in people who got infected by the actual virus. And so as a matter of fact, one thing, again, just for time's sake, I took the slide out. You may have heard about myocarditis and people getting messenger RNA vaccines, either Moderna or Pfizer. But now I do know the numbers with that. Number one, it primarily happened in men. Very, very, very few women did it happen in. And again, I had the slide here. I won't go back to it now, but in the different age categories, for example, 18 to 24, about 233 people were found to have had the myocarditis secondary to getting an mRNA vaccine. But that was against about 4 million doses being given. And so we are, again, talking about very, 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 very small numbers of the overall incidence, number one. And then number two, all of the people that develop myocarditis secondary to being vaccinated, all of them, to my knowledge, and that there was only one case that I can recall, a young man out in Colorado, one case. But all of the people resolved completely within about a 5 to 7 day period. So it turned out to be a very mild case, and all they required was rest, fluids, and either ibuprofen or naproxen, meaning either Motrin or Aleve. And they all had complete resolution. So the overall incidence rate for that, myocarditis secondary to being vaccinated, was 4 people per 100,000. Okay. But the incidence of myocarditis, which does turn out to be much more dangerous with MRI changes that are detected. Well, by the way, the myocarditis from the vaccines showed no changes on MRI when you had the cardiac MRI done. But for people who were infected with the actual virus that had myocarditis, that had cardiac MRI changes, the incidence was 400 people per 100,000. So on the one hand, we have 4 per 100,000 that had a very mild case that lasted for about a week, versus 400 people per 100,000 people who were infected by the actual virus with more permanent changes to the cardiac tissue. So yeah, the Guillain-Barré is a risk, but very, 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 very minimal chance of that happening.
So Dr. Sneed, this is one of the things I think that's starting to come up, where people are wondering, should we be getting a booster or a third shot when we've got people elsewhere in the world who still haven't gotten the first shot?
Yeah, that's a very, very good question. And I'm going to give you my own opinion. This is my opinion as an individual, not even as a community here with USF, or the scientific community or anywhere else, but I think you'll understand a little bit where I'm coming from. On the one hand, I agree when we talk about a third booster, okay, when we talk about a third shot, when many people around the world have not gotten even their first shot. Number one, I agree with that, and we need to do more to get more manufacturing of vaccines and ship more vaccines around the world to try and get more people vaccinated. However, on the other part of that coin, I strongly believe, and I know because I was watching it happen. As a matter of fact, I was part of it as a clinical investigator. I do happen to know that if the United States had not made the investment that we made to the tune of about $5 billion, as early as we decided to make the investment as part of Operation Warp Speed, it is very unlikely that we would have had any vaccines that may have just now been emerging just now, ready for distribution in 2022. So I do feel that in many ways, we have a responsibility to US taxpayers to be able to provide it for those who want it because of the very heavy investment that the rest of the world is now benefiting from. So there are two arguments to be made there, but I'm going to be a little bit provocative here. Again, this is just me as an individual. Because we have had such hesitancy in this country and for people, and we want to continue educating people. I don't believe in shaming people into it. We want to educate. We want to give people a reason to come get vaccinated. But we are reaching a point where people are either you're going to do it or you're not. For people who are very determined that they will never get vaccinated, I am kind of believing that maybe we should take their dose and now ship it overseas so that we can hopefully shut down the variants from occurring over there that may indeed come back here and undo all of the good things that we have done with our current vaccines. So there's three parts to what I just said there. They're all my opinion, but I want to make sure that all of you understand this is because of my profound impact of having my own patients come in with long COVID. The profound impact I've had with clinicians from not only across Florida, but around the country. And what's happening in terms of the number and the percentage of the people who are filtering into the hospitals who are unvaccinated. And it's anywhere from 90 to 92, 93% of all people in the hospital are unvaccinated. But I also do feel that I know for a 100% fact that if we had not made that early investment to the tune of $5 billion, and that's about the number, that we would not have been able to get through the clinical trials the way we did. We would not have had the manufacturing. We would not have had the scale up that the rest of the world is now benefiting from. So I do feel that we kind of have a responsibility to take care of Americans that indeed want to get that third boost if they need it.
Thanks, Dr. Sneed.
Dr. Sneed, you always get questions, and I've been with you on this for a long time, and I'm privileged to have been so, about which vaccine you might suggest. You always get that question. And then an additional question is, are these stories that we're hearing of these severe side effects of the vaccine, are they real?
Yeah, so after a full year, a full 10 months of watching the vaccines, watching everything, watching adverse effects, figuring out why they're occurring, how many people does it occur in. I'm much less advocating for one vaccine over another at this current moment. Again, just for time's sake, I took out a little bit of the data. Early on, many people were clamoring to get to the Pfizer over the Moderna because it kind of filtered out into the public that, well, the Pfizer had less side effects. The people that had Moderna, they felt a little bit bad and I knew at the time that, there's a 30 microgram dose in the Pfizer and a 100 microgram. So you were getting 3 times as much of the dose in the Moderna than you were the Pfizer. But now the data has come out and shown that the Moderna has had a more persistent effect with less antibody decrease over time. And we think it was because of that higher dose. And so, but also the Johnson & Johnson vaccine has proven to be very effective. And I want to be very clear about one thing. Even though the two kind of have, really all three, but the two, either Moderna, Pfizer, or Johnson & Johnson, they have different ways that they were manufactured. How we program them, okay, the programming of what we're asking the body to do, to be programmed to align directly with, against the SARS-CoV-2 virus, the way that we have programmed it is literally almost identical, because we got all of that information from the very same source with the when we got the genetic code of the SARS-CoV-2 virus. So it can be delivered in different ways to the body. Novavax is delivered in a different way to the body. But ultimately, the antibodies are all almost very similar in their ability to identify the SARS-2 virus, attach onto the spike protein, and neutralize it and prevent it from replicating. So I'm not going to really advocate for one over another. I am just going to say that you should get vaccinated. And if they have a recommendation for you to either get boosted or get a third dose, the third dose part can be a little bit more tricky. I got a really, Dr. Hill, we're going to talk about it later. I think it would be irresponsible to talk about it now. I got a really, really good piece of literature just last evening around 10 o'clock in the evening that I had a chance to read. I need to digest it a little bit more, but we are now beginning to better understand how we may be able to identify who really needs that third dose versus who may be able to wait a little bit longer. But I think it would be irresponsible for me to talk about it because I haven't fully digested everything I read because it was 10 o'clock and I was trying to go to sleep.
Oh, that sounds exciting.
Yeah, it does. It does. These TikTok stories now, these stories of these crazy side effects.
Well, I have patients come and show them to me. Some of them are to me that they're just not real. And if they are real, then we may be looking at the 1 or 2 people out of 1 million people that get vaccinated. Okay. I tell people all the time, you could go and eat the wrong piece of candy that has a piece of dye where they dyed the candy, and people have reactions to certain dyes in candy. So and it's rare, and it doesn't mean people stop taking candy. We've had more people over the past year and a half that have been harmed by taking over-the-counter NSAIDs like Motrin and Aleve than we've had actually harmed by the vaccine. So when I'm watching stuff, if people are looking at the 1 person out of 1 million, okay, and I wasn't there, and I'm not going to say no, it's impossible, that could have never happened. I mean, some of the things, it depends on specifically what you saw. I mean, if you're going to show me a TikTok video where someone got magnetized, I'm going to immediately I'm going to dispel that. Okay, but if there's anything else, I'm not going to say that it was impossible. But I'm going to tell you that it is so rare. If it did occur, if it was real, they are 1 or 2 people out of 1 million. But I can tell you right now, there's nothing more dangerous than getting infected with that virus. Nothing.
Thank you, Dr.
So true. Okay, this is a 2-part question. First is, what is the effects of COVID on the placenta? And are there any, the question is with regard to reports on women having miscarriages after getting the vaccine, how do we know if it's safe for pregnant women?
Okay, that's an outstanding question. And so now you have prompted me to I have to pull this slide up. I just have to show this one slide. And because I think it's critical, again, because scientifically people want to know, well, how do you know that? Okay, I get that question all the time, Dr. Hill. And when we try to explain it, they say, well, how do you know that? And I say, well, let me show you. So what you're looking at, scientifically, scientists have the ability to go in and get little biopsies of different organ systems. And then we can go and break it down and we can look for different receptors. So here, I talked about the Ace2 receptor. So I think you all are educated on that. And so let's just pay attention to the top portion just for a quick moment. You can see here the expression of the receptors on the various organ systems. And so the one thing I want to share with all of you, if you look at, again, at the top one, you see that the small intestines had a very high expression, which if you saw that image I showed before, the small intestines were bright red. So there's a lot of ACE2 receptors there. After that, you see the testicles in men and the sexual organs in men, very high expression. And we know for a 100% fact that there are men out there who are being negatively impacted after they've been infected by the virus. But I'm just going to go down a little bit. I'm going to go back. Okay, I apologize. Hold on. Let me get back to it. Because I was doing a high slide on that one. And so you can't. Okay, let's go back. Okay, there we go. Whoops. I didn't share a screen. Ms. Jackson, who asked that question? So, can you hear me? Can you all hear me?
I was muted. Yes, we can hear you. Sorry, I was muted. That was Catherine Kirk.
Okay, Catherine. Okay, so Catherine gets the second gold star of the day. Catherine, I want you to apply to become a student in the Tunasia College of Pharmacy, Catherine. But Catherine, let me share this with you. If you look here, you see kidney, heart, muscle, colon. Then you come right here, ovary. Now that means that the ovary actually has ACE2 on it, and therefore it could be affected by the actual virus, not the vaccine. The vaccine has no ability to be able to attach onto these organs that you're looking at. Let's go a little bit further. You see vagina, fallopian tube, pancreas. So really what I'm getting at here is that when we talk about what's the effect on the placenta, number one, for the virus, we currently, at this current moment, have not found that the virus has negatively impacted the reproductive organ system for women at the rate that it has men. Okay, so there's right now we feel that 1 out of 4 men potentially could be negatively impacted. Okay, that's a lot, 20 to 25% of men. 1 out of 4 could be negatively impacted by becoming not vaccinated, but by becoming infected by the virus. But we also found that if they got vaccinated, not only did they not have these problems, but they actually had an improvement in some of these reproductive organ functions. That's number one. Number two, when we have done surveillance from the very beginning with clinical trials beginning last year in April and May of last year, no woman that was allowed to be pregnant when they entered into the clinical trial, but scores of women all around the world became pregnant after they got their second dose of the vaccine. And they became pregnant after that. And so researchers and physicians followed these women closely for months, and the women were fine. The children were fine. There was no problem with the developing baby. All those babies have been born. Since we began to introduce the mRNA vaccines here in our country, we've been following women from day one, and we have not found an uptick in anything. We have not found a higher incidence of miscarriage than what was already happening before the pandemic. We have not found a higher incidence of anything in any category of that may involve pregnancy, that may involve a woman's ability to carry to term, or the children after the fact, we have not found one negative impact or an increase of anything that was happening above and beyond what occurred prior to the pandemic. And so that's why the latest recommendation that came out even more strongly this week is that pregnant women need to get vaccinated. And the recommendation is to get the messenger RNA vaccine. And they're saying it because now pregnant women are at such high risk because they already have more inflammatory proteins. They're putting on additional weight. They have a lot of metabolic things that are occurring, which are natural, that need to occur. But now the virus getting into the body exploits all of these bad things and thereby putting the woman at risk. Many women have died. They had to have emergency C-sections. And unfortunately, even recently, a woman with twins, they had to harvest the children. That woman died, and she had twins. And so, we hear these terrible stories over and over and over and over again. And when you look at the autopsy, when you look at everything that happened after the fact, we now know that all of those could have been prevented. Oh, they were all unvaccinated. All of that could have been prevented, hopefully, more than likely, if they had been vaccinated. So that's a great question.
Dr. Sneed, we've got about 3 people who asked almost the same question. I'm sure you can answer this very quickly. And that is the quality of the antibodies that we develop after having COVID different than those developed from the vaccine?
That's a good question. And it's very hard to quantify that. It's very hard to answer that question because we haven't done enough of what I call the quality of antibody studies to make a determinate answer across a spectrum of people. One thing that we do know, and there are two parts to that. Number one, a lot of it depends on how much of a viral load that you got in the very beginning. Did you get a heavy dose of virus in your nose, or did you get a little bit? Because your body is going to build antibodies accordingly, according to that. That's number one. And then number two, we don't know which, just for conversation's sake, I'm going to say which variant or which version of a particular type of virus you may have come into contact with that may have programmed your body to build a certain antibody against that wouldn't be as effective against something else. We just don't know the answers to that to be able to tell people definitively all the way from one part to another, whether or not that will be the case. And so one thing I can tell you is that I keep using the word programming. We have programmed the vaccines to be extremely effective against that entire spike protein, okay? And we don't know if that very same thing is occurring with each and every person that got natural immunity and natural infection. But we do know, just so you know, that we do know people who have been infected because you do have antibodies. You're very likely to have more protection against someone that had not been infected before. So we definitively know that.
Thank you, Dr. Sneed.
Dr. Sneed, could you go back and address, the differences in signs and symptoms of the flu versus COVID, and so that people can know how to distinguish those? Because, a lot of people, particularly now with ragweed out and all that, everybody's got a runny nose, sore throat, coughing, sneezing, and, we just don't know. So could you address that?
Yeah, absolutely. So one of the most hallmark things that begins to occur, well, first of all, in either case, but in particular with the SARS-CoV-2, many people eventually, and you got to remember, this is after about a 72-hour period after it's gotten in your nose because, it has deactivated the early immune system part. But people that got infected with the COVID-19 virus, they began to report kind of a pain sensation in the throat and the nose area. But rarely, oddly enough, rarely do we find sneezing is not one of the things that is a common symptom. It's not a common symptom from COVID-19 in the way that we find with either the rhinovirus or even the flu virus. That's number one. Coughing can occur, is probably going to be more prevalent with the COVID-19. although coughing is going to eventually occur, even if you have an allergy, if you got, allergies, because the postnasal drip eventually is going to lead to that coughing response from the mucus production. Now, a common viral syndrome that occurs just because of the interferon that's being released in your body is going to be fatigue. I think the fatigue has been pretty pronounced in people that get infected with the SARS-CoV-2 virus. For people that have a cold virus, you're not going to have as much of the body aches and pains. Of course, if you get infected with the flu virus, you're going to have body aches and pains. That's what the flu does to you. So these are some of the common differences, but in the early phase, when people begin to have those kind of nasal pharyngeal symptoms, it's going to be very difficult to determine, hey, well, maybe I just have the flu, or maybe I just have a cold, or could I possibly have COVID-19? So the recommendation is going to be to go get checked out. We can do a rapid test in all three. The rapid test, unfortunately, there's going to be about a 20% false negativity rate that could occur. But we can go back and detect, and further symptoms will be, fever. Fever does not always occur in COVID-19, by the way. That's why we even stopped doing temperature checks on everybody. We found that was not one of the most prevalent things that happened in everybody, except in a later phase of the infection state. So yeah, it can be a little bit, but the hallmark difference is going to be sneezing or no sneezing, and then more pronounced coughing, probably with COVID-19 than the other two, until you get to a more advanced stage of the flu, which is going to have both sneezing and cough and body ache and temperature and fatigue.
And then Dr. Sneed, if I could add on top of that, sometimes we have the loss of smell and loss of taste.
Oh yeah, well, yeah.
That might be as presenting symptoms. And I just want to take liberty, Dr. Austin and Ms. Jackson, to go to the next question, which kind of asks about, and I think you said it earlier, about why we're seeing these neurological and cognitive effects. And you mentioned about the binding of the virus to the Ace2 receptors, but according even to the slide that you showed, there's very few Ace receptors actually in the brain. So can you speak to how is it that we're seeing these kind of symptoms?
Yeah, so very quickly, because I want to get as many questions in as possible. The virus has a very unique ability to be able to almost crawl along the olfactory nerve. Okay, so the olfactory nerve, it's in your nose, and it goes right back to the stem brain of your brain, and it gets to a point where it can cross over into the brain. Okay, it can cross directly into the brain, and then it can be caught. And some, it's not the only virus that can do that. I mean, there's several viruses out there that have the capability, but this has proven to be particularly challenging, and the fact that the brain fog is very pronounced. It can occur months after you've been infected. Okay, it doesn't have to happen at the time of infection. And now the gray matter, meaning the physical manifestation of parts of the brain, are now being shown in some people to be negatively impacted. So no, it's not an Ace2 receptor, but because it just has an ability to travel along the olfactory nerve and then find its way into the brain, is how those neurological deficits are occurring. But we're also finding, because of that, brain clots that have occurred in people that were infected, and it's called the sagittal sinus, right here in the top part of the brain clots that actually unfolded from people who were infected with COVID-19. I know many people thought, the vaccine can cause that. Well, that's extremely rare, but it's more prevalent in people who had COVID-19 than the vaccine people.
Thank you, Dr. Steve.
And Tiffany asked a question about, what about the home tests? Are those just as effective as the?
The home tests are not going to be as effective or as sensitive as getting the regular PCR, the deep version. However, that's why, to be perfectly honest, if you most of the home tests, you get 2 tests in the kit. And the recommendation is that you do one and then you do the other one either 48 to 72 hours after you did the first one. Because because at that point, the sensitivity rate is not nearly as high, but the likelihood if you do a proper test of missing it both times should be pretty low. Okay, so if you happen to catch it early on, and you just didn't have enough virus, or it just wasn't enough to really stimulate that lateral flow on the little strip that looks almost like a pregnancy test. Yeah, 20% of those are going to be missed, and we know that, and we've known that about them. But if you take the average of the two tests in that one box, and I'm kind of speaking more to the Abbott right now, if you do it 48 to 72 hours apart, we find that we believe it will be less likely that you're going to miss it two times. But if you're buying it just one time and do one test and you think, I'll just save it for next week and do it again that way, that's probably not the best tactic, because you could miss it, especially, but if you're symptomatic, you need to go in and get tested anyway.
Thank you.
Dr. Austin, you see where we?
Yeah, but we still got some left. Just really quickly, Dr. Sneed, because a lot of us still don't understand this emergency use authorization and why, two of the vaccines are still in emergency use authorization and not, fully approved.
That's just a matter of data collection and process right now, to be perfectly honest. You have to have a requisite, it takes a lot. You all would not believe, well, you all might believe, because you all work for NEOGENOMICS. The NEOGENOMICS people, I think you all are probably a little bit better than a little bit more knowledgeable about big data or the concept, or you've heard the term. But when we talk about 50,000 pages of data that are being submitted that have to be reviewed by the FDA, I'm talking binders and binders and binders worth of data. They don't literally use paper anymore. It takes a long time to compile all of that data, and then it takes a long time to validate the data. Then it takes a long time for the FDA to review all that data. And so right now, what I can tell you, Moderna, they have filed for their full FDA approval. I have not kept up with Johnson & Johnson to see if they have filed for full FDA approval. But the data, the ongoing real-time data collection is very clear in terms of the overall safety, the effectiveness, but also there's a lot more that goes into an FDA approval than just safety and effectiveness. You have to be able to prove that you can, what are your manufacturing practices? Okay, they're gonna go and inspect each and every, not all of the vaccine is manufactured in just one location. They might have 3 or 4 or even more manufacturing locations where they're gonna go to every location and they're going to check to make sure that they have proper what's the word? We don't want any, Dr. Hill, help me out. We don't want stuff to get into the vaccine when it's being manufactured.
Contaminated.
Contamination. Thank you.
Pollutants,
Contamination. They're going to make sure that you have proper anti-contamination protocols. They're going to make sure that you have proper antibacterial protocols to make sure no bacteria is getting in. They're going to look at everything. Do you have enough glass vials? Where are they being manufactured? Let's go take a look at that location. Are they sturdy? Can you actually ship them without all of the vials getting broken before they reach their location? You have to provide proof of all of that. It's not just about it working in human beings or not. And you have to supply all of that data before you can apply for full FDA approval. And so we have more than enough data to support all of that right now. And it's just a matter of submitting the data to the FDA. I don't see anything that's going to prevent either Moderna or Johnson & Johnson from getting full FDA approval. And Moderna is probably going to get full FDA approval by the end of this month, I would imagine.
Yes. Well, in light of time, I'd like to close out with maybe one question, and then I'm going to put my email in the chat. And if anyone has any additional questions we haven't addressed, feel free to send them to us, and Dr. Sneed or myself will make sure we answer. But I think a good question to end on, Dr. Sneed, is, you know, is the vaccine so useful in people who've already been infected? And should we maybe be saving those doses for people who haven't had infection? Because this is always a subject that people ask.
Yeah, so the current recommendations from CDC are going to be that even if you've been infected, we want people to go and get vaccinated. Now, and let me be very clear about how I answer this, and you all can go and look it up yourself on your search engines, which I know many people do anyway, but make sure it comes from a credible source. People who have been infected and cured, okay, and they got over it just fine, are still very susceptible to having what we call long COVID develop even months after they got over it and thought they were done. People that have long COVID, except for the people that have fibrosis of the lung, people that went back and got vaccinated after they had COVID actually had an improvement of the long COVID symptoms, okay? And if it didn't clear it 100%, it lessened the severity of it. And I'm still trying to understand the mechanism of how that is occurring. Now, I'm not sure that we all the way understand why that occurs, and because it conjures up a lot of thoughts. Is the virus living somewhere that we're not aware? Is it remaining active in the tissues? I don't know if we understand that all the way. And then the other part is that we know that by getting vaccinated, that the antibodies that are going to be programmed from your vaccination are going to be programmed against the full epitopes of the virus, so that it's holding up very well against against the various variants. And so and we cannot guarantee that through natural immunity. We can't guarantee it. We don't have a good way of measuring that just yet. So the recommendation is, even that, if you've been infected, after you recover, you can go get vaccinated. Number two, for a flu vaccine, people are asking, well, can I, what about the flu vaccine? Recommendation, you can get both on the same day if you want. I would recommend different arms, but you can get both on the same day. There's no reason not to do it. And so I hope that kind of answers that question. But Dr. Hill and I are very, very concerned, and additional reporting came out this week that confirmed something that I showed to Dr. Hill and Dr. Austin back in the early part of the summer. At about 30% 30 to 33%, 1 out of 3 people are going to go on to develop long COVID symptoms. Okay. And it doesn't have to occur immediately. And you were not talking about people that were hospitalized. It could have been a very mild infection, the typical 7 to 10 day infection that you wake up 2 months later, and all of a sudden you're developing long COVID symptoms. And so one of the ways that we feel you can prevent that is by getting vaccinated. That's why I don't even want people to wait and say, well, if I get infected, I'll just go get monoclonal antibodies. Well, I don't want there to be any replication of the virus in your body, or we want to minimize that as much as possible. And so, so thank you all very much. I'm thankful for all of you for your time. I hope that my experiment of trying to bring a little bit more science into lay terms will help provide a little bit more evidence for you all to go out and more importantly, I hope it will provide enough information so that you can have a little bit more discernment against all the mis and disinformation that we're finding that's occurring on TikTok, YouTube, Facebook, and barbershops and hair salons.
And I just want to add, thanks again, Ms. Jackson, for coordinating this. Dr. Austin has placed in the chat some of the link to our e-library, but also some additional resources. And if I could, Dr. Sneed, I just want to add that not only do we have 1 out of 3 people who are getting long COVID, but 1 out of 3 that are experiencing mental health issues consequent to either being infected or the just stress of the pandemic, you know, the vaccination, the testing, the exposure, the reopening, etc. And this is as disabling and it's going to be around also for a long time. So please check out our additional resources. And again, please reach out if you have more questions. We'll come back. We love groupies. We have named Pershel one of our most favorite groupies. And so we invite you to also join our groupie club. But most importantly, we hope you learned something today, that you take care and that you'll tell others about We Care, and know that we care. And we're hoping to see you next time. So thank you.
Thank you guys for coming and doing this for us. It was awesome. Second time around was awesome as well. So thank you very much. And we are very pleased. Thank you.
Welcome. You're welcome.
Thank you.
Have a good weekend.
You too.